In this video, we're going to discuss how to solve an equation using a technique called substitution. Basically, we're going to have an equation that doesn't look like a quadratic, but by using this substitution process, we can write it as a quadratic, which then makes it easier to solve. So here's an example. Say we have x to the fourth minus 13x squared plus 36 equals 0. So this obviously is not a quadratic, it's a fourth degree polynomial on the left side, but what we notice is it kind of takes the form of a quadratic in that there's a constant term, right, the 36, there's a middle term, and then if we square the variable part of the middle term, we get the first term. So for example, if you take x squared, right, and you square it, you're going to multiply those exponents and you get x to the fourth. So that's why we say this is a quadratic type, because you have a constant term, you have a middle term, and then if you square that middle variable expression, you get the variable part of the first term. So what we can do then is we can say, all right, we're going to replace that x squared in the middle with just a single variable, just to make it easier to look at. So it doesn't matter what letter you choose as long as it's not x. I'm going to use u. So I'm going to let u take the place of x squared. So right now, my equation so far looks something like this. I've replaced x squared with u. Now if u is equal to x squared, then that means that if I square both sides, if I square u, I'm squaring x squared, which we already said is the same thing as x to the fourth, which we see in the first term. So since u is replacing x squared, and x to the fourth is basically just x squared squared, then the first term is equal to u squared. So now this makes the equation take on an actual quadratic form, and so we can solve this just like we would solve any other quadratic. We can factor, we can use the quadratic formula. I'm just going to factor this one, and I'm going to kind of leave out my steps of factoring just for the sake of space and time. So this factors as u minus 4 times u minus 9. So to solve for u, we would set each of those factors equal to 0. Now the thing we want to remember is we weren't actually trying to solve for u, right? The original equation had x, so we actually want to solve this for x. So at some point, it doesn't matter entirely when, but at some point you want to go back and replace those u's with x squared, because then you will be able to solve for x. So u was equal to x squared. So really what we're solving here is x squared minus 4 equals 0, and x squared minus 9 equals 0. So now we have two quadratic equations to solve, and again, you can factor, you can add, the 4 over and use the square root property, however you want to solve those quadratics, but you're going to get two solutions from each, so plus and minus 2 from the first one and plus and minus 3 from the second one.